In the absence of experimentally determined target structures, drug design projects frequently rely on pharmacophore modeling tools to identify and modify new lead compounds. Before it's possible to perform database screens using pharmacophore tools, it's first necessary to create a pharmacophore model suitable for this purpose. This can be done using the wizard-like Develop Pharmacophore Model interface for phase. The end goal of the pharmacophore development workflow is to identify a spatial arrangement of chemical features that confer activity toward a given target. The phase interface is found within Maestro, which is the interface and visualization tool used for many different Schrödinger programs. To open the Develop Pharmacophore Model interface within Maestro, we head up to the Applications menu, find Phase, and choose Develop Pharmacophore Model, as you can see here. There are also other interfaces to various other phase tools that we can open. However, before you develop a pharmacophore model within Maestro, it's always a good idea to work within a saved Maestro project. So before we run any calculations, the very first step is to make sure that our Maestro session is saved for future use by heading up to the Project menu and choosing Save As. We need only type a project name. In this case, we'll name it phase endothelin example.project, where the .prj suffix denotes a Maestro project, and all our subsequent work will be saved to disk for future use. So for example, this means that we can close a Maestro session halfway through the pharmacophore development workflow, restart Maestro the next day, and pick up exactly where we left off. It's worth noting that once we're working in a saved Maestro project, all of our work is automatically written to disk, which means that we don't have to constantly press Ctrl-S to save intermediate results. The first thing that we need when creating a pharmacophore model using phase is a set of active ligands. Phase will search for spatial arrangement of pharmacophore features, or site points, that are common amongst active ligands, and use these to discern a pharmacophore model that describes active compounds in general. I'll go ahead and import our ligand file using the Import Structures button in the Maestro toolbar. This is a fairly self-explanatory file browser. We just need to click on the file name of our known active compounds, and then click the Import button to bring those structures into Maestro. It's also possible to build the structures using Maestro's Build panel, but for the sake of keeping things focused on phase, we'll just use the imported file endo1conf.me. In the next video, we'll get started with the process of actually using the compounds in this file, a series of endothelin binders with known activities, to create a pharmacophore model.